let's talk about edge devices within the restaurant and retail industry. What exactly does extending hardware life cycles mean?
You look at the ISV and the solution provider community, the best latest solutions for these markets are built on Android. Android is the biggest developer ecosystem in the world in the history of humankind.
Can you give me a practical example to put this into perspective?
We're Android geeks. We work at the operating system level. We have relationships with the chip vendors that provide the enabling silicon to run these things. And so we actually built our own Android OS.
Future trends you probably observe within this space?
The Wi-Fi group, if you will come up with some new spec that'll make it robust, but something exists today and it's proven in its private 5G networks. So 5G has low latency. It can handle the communication streams that are required for these robots to be coordinated. You're already seeing it in warehousing and mining.
Welcome to the Tech Transform podcast, where we have a weekly conversation with people impacting the enterprise tech landscape. My name is Shubhangi Dua, a podcast producer and B2B tech journalist at EM360 Tech, and I will be your host today. In this episode, I am speaking with Keith Szot, the SVP Chief Evangelist at Esper, about the strategies for extending the lifespan of edge devices. Especially, we will be touching up on the application of edge AI and specialized operating systems. Hi, Keith. How are you today?
I'm doing great, Subbu. How about yourself?
I'm great as well. I would just dive into the agenda right away. What did you have in mind for our audience, and what do you really want to convey to them?
Well, starting out with IT ops is a tough endeavor. If you are running revenue producing key business operating systems that are out in the field, it's not an easy job. And with everything that's going on these days, it's not getting any easier. Considering tariffs, the impact of AI in terms of how you look at your hardware refresh cycle, it's really tough. And I hope through this podcast that key decision makers and frontline people too get some ideas and context of how they can navigate these uncertain times, but additionally, how to potentially take advantage of it to advance their business using technology. And hopefully Esper will be a part of that.
So let's talk about edge devices, since that's the agenda. We're trying to talk about this particular field in terms of, I know we want to touch up on AI and the restaurant and retail industry particularly. So within this context of edge devices that are commonly used within the restaurant and retail industry, what exactly does extending hardware life cycles mean? From a primarily, I would say, software-centric perspective?
Yeah, sure. But you do need to take the hardware aspect into account. And what I mean by that is the mechanical design and the industrial design of the hardware, because these devices are hit on every single day by many different types of people. And if you want to extend the life, they must be physically capable of taking that usage. And so that's kind of the baseline, is that you need a sufficiently rugged device that over the years can still operate to spec. So that's like the first level. And so, we see a lot of consumer tablets that are used for these types of use cases as edge devices, dedicated devices as we call them, and they're not designed to survive. So the concept of extending the hardware lifecycle gets much tougher with that kind of hardware, but it's very common to see specially built devices for these vertical markets from major OEMs. And those tend to have the ruggedness and the durability that they're essentially candidates to extend the hardware lifecycle. Then you get to the next part of the system resources that are available on the hardware. The CPUs, the supporting technology that goes into these devices is always changing. And you have to look at, do you have sufficient specs in system resources to still fit into the use case that you want to accomplish today? So that's kind of the baseline that you have to look at. Then it next moves to the operating system. And this is the big one that impacts the life cycle. You look at what's happening with Windows and AI. That's a great case in point. Windows was the standard for a lot of these use cases. You think of POS, digital signage, kitchen displays. But for better or for worse, Microsoft is really driven by more of a consumer cycle in terms of competing in the market. You see the same thing to some extent with Android and iOS. We'll get to that in a minute. But for them, they really needed to move hard on AI. The impact is that the older versions of Windows that a lot of our customers depend on are going end of life, and they cannot get things like security patches to be able to protect their enterprise network infrastructure. And the hardware is insufficient to run the newer version of Windows. So they're kind of stuck. It really is forcing them, if they stayed on Windows, to go into this hardware refresh cycle. Now, at the same time, there's another dynamic going on where Android is becoming the platform of choice for creating the solutions that these types of customers use and deploy. You look at the ISV and the solution provider community, the best, latest solutions for these markets are built on Android. You look at enterprise developers. If you're developing in-house, arguably it's a lot easier to find an Android developer and build a team to focus on creating Android applications than it is in Windows. Android is the biggest developer ecosystem in the world, in the history of humankind. Thus, it's pushing the industry towards Android. But that kind of gets you into this rub of, well, how do you accomplish that? There's one final part of this too, is that the Android UX is more intuitive. People use phones all the time. And even if you're an iOS user, the paradigm, if you go to Android, still has a familiarity where the bar to understand how to use the software in the device arguably is lower than you'll see with Windows, because most people just aren't as familiar with the Windows experience as they used to be. But they are very, very familiar with the phone experience and therefore the Android OS. Now that goes back to Esper. We saw this shift coming a few years ago, and we saw it as an opportunity to be able to help customers. And that led to us focusing on how can we help them extend the life of the hardware in a way that made sense for the customer and for Esper.
Can you give me a practical example to put this into perspective? Like if I'm at a restaurant and I'm using a kiosk, or what is the problem that I would face? And then what is the B2B perspective where my company would have to employ a solution to be able to avoid that life cycle issue? A very practical example of this.
Well, let's run it through kind of going into that one, which is if you're looking at how you maintain these fleets, if you choose an operating system that has a fast refresh cycle, it's going to be tough on you. And that's what Windows represents, essentially. And they are driven by many different pressures in terms of how they maintain their operating system. It's true to say that Android has some of these pressures too. If you're familiar with how Google licenses and provides Android, they have a program called GMS. And that's what you see on the phones that the billions of people use in the world. And that is very similar to Windows in that it's tied to the smartphone hardware refresh cycle. So you see it constantly shifting. Google releases a new version of Android every year. Android 14, Android 15, Android 16. It's like a TikTok, a metronome in terms of these releases. And that can be very hard to keep up with. But what a lot of people don't know is Google also makes Android available as an open source project, literally full source code. And with that, you can take it and utilize it yourself and be off that train that drives the consumer market. That is a unique aspect of Android that is not present with Windows. And that enables us to be able to do what we do relative to extending hardware lifecycle. Now, it's important to note that Google also has a sub-program of GMS called EDLA. And Google recognized that for vertical market OEMs, they had a longer lifespan that they were achieving, 7 to 10 years, and they wanted them to do it on Android. So they have a special licensing program that allows these devices to be kept up to date for a longer period of time and still get the Google services. This goes back to you need to patch these devices. The reputation of Android being insecure is incorrect. It's actually very secure. It's based on the Linux kernel, but even with that, there will be vulnerabilities that are identified. You need to reach those devices and deliver patches to cover them. And so you kind of need that whole package with the support to be able to handle this. Now, it comes to how do we address this for a customer? And I think a great example to be able to use is we had a company that is a big seller of tacos. You can imagine who they are. They sell a ton of tacos. And they strategically decided that they wanted to move to Android. But they had this problem that their entire POS system, their entire fleet in store was based on Windows. And they didn't have capital budget to be able to purchase all new hardware to run Android. So they were stuck. Now, going back to us seeing the opportunity, we're Android geeks. We work at the operating system level. We have relationships with the chip vendors that provide the enabling silicon to run these things. And so we actually built our own Android OS. We did this off the open source distribution. It's called Esper Foundation for Android. And we saw a gap in the market in terms of the focus on Android for x86 and specifically for Intel x86. So that's some of the context is most of this installed base utilizes Intel x86 silicon. And that's what Windows is naturally built upon. But based on the market opportunity and pressures that Google was faced with or chasing after, they divested from supporting Android on x86. It wasn't a focus for them, and that meant that that market was fading away. So there really wasn't any choice for companies to run on Intel hardware. We worked very closely with Intel, and we took our Android build, which again is called Foundation, that has specialized features for these dedicated device use cases, and have it run on Intel silicon. That was the starting point. So with that, we did a go-to-market around it. And honestly, we didn't know exactly what we would get. And this is 2019, by the way, when we went out with it. And we found a connection with this particular company, and they laid out their problem. They needed to get to Android. They don't have the money to buy all the new hardware right now. And so how could we help them? And so this goes back to originally we kind of envisioned what we did with Foundation as more of a factory thing. You know what I mean? You're making new hardware, you want to ship with Android. And that put us down a path of, how can we help them with this? And that's where the concept of what we call the Windows to Android flip came up. And so there was a lot of back and forth and work together. We got evaluated really hard by this particular customer, by the way, as you can imagine. And through that, developed a technique to remotely flip a Windows device to Android without touch in the end.
Can I just ask how and where does AI come into the picture then?
Oh, we're getting to AI. Yes. For this one, it is getting a bootstrap file to a Windows device. So these devices have RMN. They're managed in some way, shape, or form. So from the IT operator perspective, if they can get this bootstrap file to the device, it would then start our installer. And our installer has the ability to shrink the Windows partition, meaning you can preserve Windows on that device if you wish, and install our Esper Foundation for Android x86. That's the full name, I know. It's kind of long, but we have to be very precise with how we name it. And from that, you start the conversion process and install our Foundation Android on that machine. Now, we encountered this at the start because you can imagine that customers are a little hesitant about this and they want to see how it goes. And so they wanted the fallback to preserve to Windows, and thus they gave up some disk space for keeping the Windows installation on. Once things got rolling, then they were fine doing what we call bare metal install. Literally, you put this file down, you bootstrap it, it goes into the installer, it replaces Windows with Android. Now, this is where our device management infrastructure comes into play. Because what do you do after that? How do you get that device prepared and ready? We have another technique that we call seamless provision. provisioning is the process of setting up the device for deployment, right? It's things like what are the settings, what are the policy you want to have on it, what app set do you want to have installed, what apps do you want to make visible, do you want it in kiosk mode, all that kind of stuff. What we do is we have a cloud-driven approach that an IT operator in the cloud can create a blueprint. And the blueprint has all that policy settings, application install defined in it. And you can associate devices ahead of time to that blueprint. So upon first boot, they just check in with our service through our Android. They know exactly how they have to be set up. We put our agent on it. We set it all up. And without a touch, the device is ready to go. Now, here's the interesting thing that you find, right? You build these enterprise solutions on Android. You have this older hardware with less capable CPUs. It works great because Android needs less system resources. And so this is part of the investigation the customer has to do in terms of like the performance of the device, the application. You have to validate it with your enterprise app team or your ISV relative to what you're doing. So there is prep work that's required to prepare for this. But what we found is that Android is lighter. It doesn't need as much. And so it performs very well on this older hardware where Windows is starting to get bogged down because it needs more and more and more. This also took us into consideration for field techs. It is not a pure play. Sometimes you have problem children out in the field, and what do you do with them? And so this concept of remotely flipping that usually is staged, think of it as a ramp because no customer is going to do it.
Are you referring to the Android flip?
Yes. Referring to the Android flip, right? They're going to have a process where they stage it out. They have a lot of constituents they need to deal with, franchisees, and just the infrastructure of the stores. And so they have a plan, and it takes them a while to be able to do it. But the field techs, a lot of times, they need to connect with the device. And so we actually make a utility in addition that we call Firebolt. And so you can configure essentially a USB stick with your OS build, and you can go on and plug it into a machine that you're dealing with and drive this conversion process. So providing a lot of this flexibility.
Honestly, some of it, like especially when you first mentioned that now you can do it without touch, and earlier you would have to like dismantle the hardware itself, and now it's taken a more, well, a software-centric approach. It sounds like a dream to me, but clearly we're advancing so fast. So it's amazing that we're heading in a more very automation space, and we will come to that. We will definitely come to that. But there's another question that I wanted to ask before we move to the futuristic aspect of it. What specific software solutions or management strategies are most effective at prolonging the usability of existing hardware? How can we retain what's already there without requiring immediate upgrades?
I think part of it is like when you make that choice, don't pick an OS that's going to be on a fast track. That's kind of the base. And, you know, some of it you can't foresee. Like who saw AI crashing on us like a huge wave that basically drove a bunch of changes to OSs to accommodate this, that you have no say in what the vendor strategy is, right? They're going to chase what they're going to chase. And so that's why having more control over that can be better. And so that would point to Android open source being a good choice. We've seen what has happened with Windows. And I think it goes back to some of the core principles I talked about before. If you're going to buy a consumer tablet for these use cases, do not expect it to last a long time. I've seen a lot of different things that erupt from using those devices. And as long as you're good with the price point and you map out how long it'll last, all's good. But know that you're going to need to replace it within a shorter period of time. If you have robust industrial and mechanical design around the device, then you can expect physically it's going to hold up, and get the right OS that you can keep it patched in a way that has the full infrastructure you need to be able to keep it going.
Tell me a little bit more about the edge AI capabilities that you are currently working on. And there's a little example actually that I wanted to provide just as context. For instance, a restaurant chain looking to implement age verification at self-service kiosks without reliable internet. What would be the more suitable approach in such a scenario? And what are the primary reasons for this recommendation?
That goes to one of our partners' customers, Minor Decliner. We actually did this with them. And so leaking back, you have this issue. If you want to do AI, how are you going to do it? And your installed base will not have the capability to do inference on the edge. So it's kind of a tension against what I just talked about, right? You want to flip these Windows devices to Android, but yet you have this AI pressure, and they're not going to be able to do AI on the edge very well. You see it start out with cloud-based, right? You do your inference in the cloud. And so, you're going to train your model in the cloud, and then once it's ready to perform, you can keep it in the cloud and use cloud-based resources to do that inference, basically whatever AI job at hand that you're using it for. And in this particular example, it's a robust age verification system that uses computer vision with the person, with the ID, and various techniques that are on the back end to be able to do further checks based on what the end customer pays for. And so if you use cloud, there are potential issues with it for how our target customers work. The most basic is cost. You are on somebody else's train and you're going to pay based on utilization for doing that inference. And so you can get surprised by that. You can read stories about companies that do AI prototypes and they get the bill and they're like, whoa, we did not expect this. So you have to watch that carefully. True to say, cloud inference costs are decreasing very rapidly, but you cannot get around the fact that you need an external internet connection to be able to perform this inference. So you have two things. Is the connection even there? And what is the latency involved with the communication to the cloud when you're performing whatever AI interaction you want? And if you think about something like buying from a kiosk, you want it to be snappy, right? This is a customer experience. You think about having a kiosk to create personalized experiences, AI-driven drive-through type of scenarios. We as customers and employees as well do not want lag. We don't want misinterpretation. We want this thing to be as robust as possible. And that means you have to do it on-prem. You have to do it at the store location, right? It links us back around. Well, what do you do when you have this old hardware? So what we came up with is a technique to deploy a single capable box, Linux-based. It is managed by Esper, that has the AI capabilities, whether it's a GPU or an NPU. And from that, you can then, using what I call our AI SDK, extend your applications on hardware that can't do inference to utilize this box to perform the AI operations. We take it a step further that now you're looking at, instead of having like one model that sits in the cloud that you can easily control, this is kind of like the cloud developer perspective with Kubernetes, right? Updating a model is super easy. You basically push a button, all the cloud stuff happens, you're good to go. It's a lot harder when you permutate this model across all these different locations. You need to manage it. And that's what we do. Part of our core is artifact management, whether it's an app, whether it's a content file, whether it's an operating system update, that's what we do.
And what about in terms of managing them? So is it now are AI agents also coming in the picture to sort of help manage these different tasks that you need to do?
So you're asking a very interesting but kind of separate question relative to that, right? So the first part that I'll jump on is agents with retailers and restaurants. It's absolutely coming, right? And this is an exciting thing of how can you create a better customer experience, and how can you help the employee be more productive and arguably make it more fun for them, because a lot of those jobs are tough and they're just inundated. And if agentic AI can help them, it's all about keeping the human in the loop. And I think companies are trying to figure this out, because it's just like this complete automation thing, in my opinion, is not the best thing, because people like to work with people. We're human, we're social. And if you make it too extreme of agentic AI, it's not going to work, in my opinion. However, if you apply it in the right way, you can create a better experience for everybody involved. And so agentic AI is going to be huge with that. Then you step back to say, well, how can you use AI in what I would call traditionally SaaS companies? And that's something that we're focused very hard on ourselves. We look at it very carefully, because when you are controlling these fleets, like hundreds to thousands to tens of thousands and more devices, a hallucination can be very bad. So really our philosophy is to start out with helping the operator be more productive. And we have an Andy bot built into our console now that is essentially representing our documentation set to more easily find answers to questions. Instead of digging through docs, Google search, you just ask our Andy bot and it will help you figure out your answer. That's kind of the starting point. But really we view it as how do we superpower the human IT operator and start to take a load off of them, which by the way is the same philosophy I think that you're going to see in retail and restaurants with consumers and employees. And that will evolve over time when you get hallucinations out and you can start to become much more agentic in how you approach managing these devices.
If you had to envision the role of edge AI and specialized operating systems within the restaurant and retail sectors, but in I would say 5 to 10 years time, how do you see it? Where is it?
I think the big one is going to be the rise of physical AI. And this is kind of the term. I mean, it's robots, essentially, right? And, you already see it in hospitality, someone in QSR. I was just at a hotel where they had a robot that will go deliver towels and things to your room. It exists today, but it's relatively rudimentary. It will evolve very, very quickly. This is another thing from the NVIDIA GTC conference, that NVIDIA is all in on robotics. The enabling hardware technology, like things like arms, humanoid forms, things like that, is starting to proliferate. And this needs AI to be able to operate. And NVIDIA developed something called Omniverse. It's basically an environment where you can simulate deployment of robots in physical locations. You can upload a CAD file, right? You lay out your use case. And you can pick from different robots that you can just drop in and see how they perform, right? By defining your task. And this will also train the models for each individual robot for the tasks they need to perform and how they interact with each other and with humans. And this is all in a digital twin. And then when you're done with that, and I don't think it's there yet, but it's going to be as simple as, okay, let's buy these things now, right? Let's make sure that we have the models put on them and then you could deploy. So literally a restaurant could say, here's my operation. I want to go robotic. Okay, these are the use cases I want to do. Let's simulate it, ready to go, hit a button, buy, and let's deploy it at the restaurant. I think that's the world that we're going to.
It sounds, honestly, I am not very optimistic about that world. It sounds a bit scary for AI to be entering robots, because even now when you I know ChatGPT or Gemini, they have strict rules about the way you ask questions, certain keywords you use. For instance, when we talk about nuclear war, if you have any questions about that, it will push back. It will not answer. But there are also hackers who have kind of passed that wall and they have been able to get instructions on certain for instance, I think I wrote an article about a hacker actually getting the exact instructions to creating a fertilizer bomb. So it's still, obviously, even AI is not perfect. So it makes me, it's scary to think that if AI enters robots and a hacker or I don't know, a person who is well in tune with this industry and knows their technology too well, how they would be able to overcome its walls against in a robot. And then, I don't know, the action.
We'll see, right? I'm with you on that one. I think part of it is, the foundational models, they're so huge, right? This is like OpenAI, Perplexity, all that it's really tough to, lock them down and keep them secure and, if you will, on task per the definition that those suppliers have defined for them. When you go to these specialized use cases, they're going to be much smaller models, tighter. And so it goes back to humans still need to take the steps to ensure that the protection is robust enough so that they do not become nefarious or manipulated to be nefarious, right? Because with physical AI, humans are on the line, right? If you have a robot making French fries in a restaurant and it goes crazy, it could really, really hurt or even kill somebody. And so that is a concern. But I think doing that protection and that work is easier with these types of use cases than it is with what you see with these foundational models.
If there are any more future trends you probably observe within this space as well that impact like management and optimization in the restaurant and retail industry particularly?
Yeah. Well, when you talk about the rise of physical AI, there's something else that's going to be pulled with it. If you have multiple robots that have movement and need to interact with each other, you need a robust communication means between those robots so that way they can be coordinated. For better or for worse, Wi-Fi doesn't have the characteristics that are required for that. Maybe the Wi-Fi group, if you will come up with some new spec that'll make it robust, but something exists today and it's proven in its private 5G networks. So 5G has low latency. It can handle the communication streams that are required for these robots to be coordinated. You're already seeing it in warehousing and mining. We have customers that do this kind of stuff that I think it's getting perfected that you could conceivably see deployment of 5G in a restaurant for use by that restaurant that then allows that coordination on the internet and could be the backbone to the internet too. So that's one, which is like check out and understand 5G. I think another trend to really look at is quantum computing. I don't know if you've heard of Q-Day. Q-Day is the day when a quantum computer can brute force break the public key infrastructure encryption methods. It's basically everything that underpins how we protect information. And by the way, is how credit card transactions are done, how secure communications are done, how encrypted files are stored to protect them. And there's going to be a point where quantum computers can break it. And so, if I'm a CISO running IT ops team, I want to be at least aware of this and investigate some of what's called post-quantum cryptography. Yeah, so there's a couple of algorithms that have been proven to be considered to be quantum safe. There's one, Crystal's Kyber, NTRU. I would suggest like reading up about it. And there are some practical ways that you can start to use this today. And that goes with using quantum mechanics for key generation, right? Because one of the hairiest operations is, hey, I got a private key to encrypt stuff. In order to get it encrypted, I have to move it to somewhere else, essentially. And that exposes you to if you get a human in the middle attack, boom, you get that key, you can decrypt that. And so how do you handle that? Via quantum mechanics, you can actually create a key between two different places on the planet, in the universe, without anyone being able to basically detect it. If it is detected, you will know. And you can throw away that key. That kind of stuff blows my mind, right? I'm not a physicist, but it's super cool.
I feel you. It's one of my favorite topics to look into, and that's actually something that I hope to continue researching about and host podcasts about here, because we've only written about quantum computing in the more encryption phase because we cover cybersecurity. But in terms of like the other aspects, it's so fascinating. There are scientists even saying that quantum computing can basically know what the black hole is all about. It'll detect all the mysteries of the world. And I think it's already starting to sort of come in terms of encryption for sure. We've seen that. I think the company Seek, I think that's the company that's, I can't remember what it was, but they have partnered with NVIDIA to create some sort of, it was some sort of a chip collaboration, if I'm not wrong, but I'll look into that a bit more.
Yeah, a few more. We talked about how device management will fit into AI, right? But I think the other one, which is always interesting to me, are hardware innovations to create these new experiences. I'll give you two examples. Starting to see transparent kiosk displays. What you do with that, we'll see, but you can actually see through them, but yet create a visual experience. And so, experimentation around that of what does that mean in a retailer or in a restaurant is pretty cool. And then circular displays are another one. And it's interesting how this happened in that you think about, well, how would you get a circular display? Well, you think about watches, right? All these watches have circular displays, and that means operating systems and applications that are built for something that's a circle is mainstream now. And like 20 years ago, it wasn't. And so people are seeing the opportunity to take the concept of a watch and make a bigger screen. And how would you use that? Well, I think cosmetics is like a great example at retail, right? You would probably prefer to see a circular screen than something that is rectangular in terms of having an AI interactive experience as you make choices for cosmetics, earrings, things like that. And so that those are some of the things to me that I'm curious to see how they manifest itself through the device creation system and how end customers take advantage of it to create new experiences, new revenue opportunities, new ways of doing business.
That's very interesting. So, coming to the end of the podcast now, would you be able to summarize one key takeaway in less than 60 seconds for CIOs, CTOs, CISOs, and other IT decision makers out there?
It's tough times, but you can still catch the latest technology waves, whether it's Android, AI, automation, without breaking your capital budget by extending the hardware you already own. Go for it.
That's really great advice. And that brings us to the end of today's insightful discussion. Thank you so much, Keith, for sharing your invaluable expertise with us and your perspectives. For more information on what we've talked about, please head on over to esper.io. We'll be back soon with another episode in our podcast series. Until then, make sure you subscribe to this podcast on all major platforms and follow the conversation on our socials at EM360Tech on Twitter and LinkedIn. And for more great daily content, head on over to em360tech.com. Thank you so much.